JavaScript runs nearly every website you use. It is what powers buttons, apps, animations, dropdowns, and even this YouTube video player. So, learning JavaScript is the best choice you can make if you want to build amazing websites or even become a full-stack developer. In this crash course, I will teach you all the fundamentals like variables, if statements, loops, and more, so you can finally make sense of all those confusing beginner concepts. If we haven't met yet, my name is Fabian and you're watching Coding to Go. We teach thousands of students both on YouTube and Udemy the most relevant coding concepts in just a few minutes. But first, let's talk about what JavaScript actually is. JavaScript was created in 1995 with one big goal: to make websites dynamic and interactive right inside the browser. In other words, JavaScript is a client-side language. But what does this mean? Most programming languages, like PHP or Python, run on the server, and when you interact with such a website, your browser has to send a request, wait for the server to respond, and then update what you see. That delay may only be a second, but it really breaks the flow. But JavaScript is different. It runs directly in your browser, on your device, which means it can respond instantly. It is what makes modern web development possible. But interestingly, JavaScript has grown far beyond the browser. Today, JavaScript powers almost everything, from server-side applications with Node.js to mobile apps with React Native. You can even build games, run AI tools, or create full-stack web apps all with JavaScript. Therefore, it's no surprise that JavaScript has quickly become the most popular programming language in the world. But I know learning JavaScript can feel like a real challenge. It's not as easy as HTML and CSS, and there are all sorts of confusing behaviors and edge cases that are really different to many other programming languages. But also because JavaScript keeps evolving very fast. Every year, new features are added to the ECMAScript standard, bringing new syntax, new rules, and new ways of writing code. And while that's exciting, it also means we constantly have to adapt, keep up with the changes, and relearn things we thought we already knew. So now that you know what JavaScript is and why it matters, let's get hands-on. In the next few minutes, you're going to learn all the fundamental JavaScript concepts you need to write your first programs. What software do I need to get started? What is the JavaScript syntax? How do you use tools like variables, operators, if statements, loops, and functions to write the business logic behind the scenes of a website? The next part of this YouTube video are actually Udemy lessons taken straight from my full JavaScript Udemy course. We have decided to publish these beginner lessons completely for free here on YouTube, so you can try them out and start writing real code right away. And hey, maybe you enjoy the style and want to keep going, then you can always get the full course with exciting projects and all the fun stuff available on Udemy. Let's jump in. Welcome back. Before we can write our first JavaScript program, we need the right tools. Luckily, JavaScript doesn't require much. We only need a web browser, like Google Chrome, and a code editor, like Visual Studio Code. You probably already have a browser installed on your computer, whether that is Firefox, Safari, they're all totally fine. So we just need to install the code editor. But why do we need a code editor? A code editor is a special program designed for writing code. It helps you write code more easily, spot mistakes quickly, organize your files, and run and test your programs. You could technically write JavaScript in a simple text editor like Notepad. But trust me, using a proper code editor will make your life much easier. That's why in this course we're going to use Visual Studio Code, one of the most popular and beginner-friendly code editors available. But of course, if you already have a favorite code editor, you can continue using it. To get started with Visual Studio Code, we go to the official VS Code website. Here, we click on the download button for our operating system. Then we open the downloaded file and follow the instructions to install it. Once the installation is complete, open the Visual Studio Code application. Great, now you're ready to write code. Before we start coding, let's organize our work. For this, we want to create a project folder where we're going to put all our files. You can create this folder anywhere. I simply put it on the desktop and call it something like JS Basics. Then we open this file in Visual Studio Code. Inside VS Code, go to File, Open Folder, and navigate to that project folder. When you have the folder JS Basics, click on Select Folder. Now we are in the project folder in Visual Studio Code, and this is where we'll write our first JavaScript code in the upcoming lessons. However, to run JavaScript, we need an HTML file. But why is that? Because JavaScript is a client-side language. It runs in the browser, and it's usually loaded through a website. And for that, we need an HTML file. So let's create a file, index.html. Here we can use the exclamation mark and press Enter. This will generate basic HTML boilerplate code. You will now see a few common HTML elements. And very important, if you're not familiar with HTML, I recommend checking out the HTML crash course at the end of this course. Don't worry, HTML is a very simple language and you only need to understand a few basics for now. To test things out, we can add a heading inside the body tag. h1, hello JavaScript. Then we save the file. Now let's open the HTML file in the browser. To do that, open your project folder in your File Explorer. And then open the index.html Google Chrome. Now we see the HTML page in the browser. This works great. Now, before we conclude this lesson, let's install a very helpful extension that's called Live Server. This will make your development process much easier. To install an extension in Visual Studio Code, you can click on this icon here, or go to View and click on Extensions. Here we search for Live Server. And then we simply click on Install. Once the Live Server is installed, you may need to close and reopen VS Code so that it works. Now what the Live Server does is it automatically refreshes the browser whenever we change something to our code. So we no longer need to manually reload the page every time we update something. This makes the development process much faster and more convenient. To use the Live Server, just go to the HTML file and right-click anywhere in the file. Here, click on Open with Live Server. Then your file will open in the browser. If you make any change in the code and save the file, then the update will instantly appear in the browser. It automatically refreshes whenever you change and save the file. Great. With that, we have successfully set up our development environment. Now we're ready to start working with JavaScript in the next lessons. Welcome back. In this lesson, we'll create our first JavaScript program. To get started, open your code editor. And the first thing we need is an HTML file, because we want to use JavaScript in the browser. As usual, we call it index.html. Here, we use the exclamation mark shortcut to generate some HTML boilerplate code. Now let's add JavaScript to the page. We do this using the script tag. You can place the script tag wherever you want. I like to put it either in the head or at the bottom of our body element. Anything you write here between the opening and closing script tag will be interpreted as JavaScript by the browser. So this is where we can start writing our JavaScript code. Let's start by creating a simple pop-up message. For this, we can use the alert command. Just type the word alert followed by parentheses. Inside the parentheses, we add the text hello world. When we work with text, we have to put quotation marks around it to make clear that we are using text and not a variable or something else, because many words in JavaScript have an actual meaning. And to make sure that we are just using plain English words, we put this inside quotation marks. This is also called a string, but more on that later. Then we end this statement with a semicolon. Now we save the HTML file and open it in the browser. Here we see a pop-up window displaying the text hello world. This means that the browser has executed the JavaScript code correctly. If you don't see the pop-up, make sure that you spelled everything correctly. Let's take a closer look to our code. Alert, and then in parentheses and quotation marks, hello world, semicolon at the end. You might be wondering what these parentheses, quotes, and semicolons mean. These symbols are part of the JavaScript syntax, a set of rules that the programming language follows. You have to use the correct syntax of the programming language so the computer can follow your instructions properly. If the computer does not understand what you want, then the program will crash and you will get a syntax error. For example, if you forget to close the parentheses, the code won't work. Luckily, Visual Studio Code immediately tells us that we have an error. We can also find this error message if we go to the console in the browser's developer tools. So right-click Inspect the page and go to the tab Console. Here we get the message syntax error, missing closing parentheses after argument list. So whenever your program doesn't work and you don't know why, it's worth looking at the console to see if you get an error message. Especially in the future when your code will be very long, then it might be difficult to find the error. Just look here at the console and it might tell you where you can find it. You must always make sure that you have used the rules of JavaScript correctly. In the next lesson, you will learn more about the syntax of JavaScript. Now that we have created a simple pop-up, let's change the message inside the pop-up. You can easily do this by replacing the hello world string with another text, such as hello JavaScript. When you reload the page, the new message will appear in the pop-up. But what happens when we have more than one instruction here? Let's copy this alert command a few times, and each time with a different message inside the parentheses. If we save the file and reload the page, The browser will go through all of these instructions, and it will follow the instructions in the correct order. And this is what JavaScript is all about. You give instructions to the browser, and the browser follows your instructions, one after the other. If you add several alert commands with different messages, the browser will display them one after the other, following the exact order in which they appear in the code. The browser reads and executes your code from top to bottom, line by line. And by the way, you can also write all of these instructions in one single line of code. It still works. And this is why it's important to use a semicolon after each command, as this helps to clearly separate the commands. If we write these commands one below the other, we don't necessarily have to use semicolons. We can remove them completely and it will still work. But it is still a good practice to use them to indicate where one command ends. Now let's remove the alert commands and try something different. Probably the main purpose of JavaScript is the ability to interact with HTML and CSS. For example, we can change the background color of the website. For this, we write the following statement: document.body.style.background equals, and then in quotation marks, blue. If we save the file, the background of our web page turns blue. So this statement basically tells the browser to change the CSS code of the body element. Here we access the document object, which represents the entire web page. Inside the document, we want to access the body, so we write .body. And the body has the so-called style property, so we access the style. And the style has the background, and the background can be set to blue. This line of code is an example of how JavaScript can modify the HTML and CSS on your page. And don't worry if it seems confusing right now. We'll dive deeper into the document object model later in the course. For now, it's important to get comfortable with the basics of programming in JavaScript. Welcome back. In this lesson, I will show you a different way to add JavaScript to your web page. When you work on bigger projects, your JavaScript code can get very long, sometimes hundreds or even thousands of lines. If you place all the code directly inside your HTML file, it can make the code messy and difficult to read. To keep things organized, it's better to move your JavaScript code to a separate file, just like we do this with CSS. For this, simply create a new file and name it something like app.js. The file name extension .js stands for JavaScript. Inside app.js, you can write your JavaScript code. For example, write an alert command again. Then we go back to the HTML file. To include this JavaScript file in HTML, we have to write the script tag again. Here we have to use the source attribute. The source attribute is where we specify the relative path to our JavaScript file. Since the JavaScript file is in the same folder as the HTML file, we can just pass the name app.js. If you have your JavaScript file somewhere else, then you have to write the names of the folders as well. For example, javascript/app.js. Now, if we open the HTML file in the browser, it will show you the alert dialog of our external JavaScript file. So we successfully implemented external JavaScript on our page. By using an external JavaScript file, your code becomes more readable and easier to manage. Plus, you can reuse the same JavaScript file across multiple HTML pages without copying and pasting the code. So you can use the same file on many different HTML pages. As your projects grow, you might have multiple JavaScript files for different features, like handling user inputs, validating forms, or creating scroll animations. Then it might make sense to create different JavaScript files for all of these cases. To include these different JavaScript files, simply add more script tags to your HTML file. Each script tag will simply get the source attribute and reference the respective file. This method keeps your code organized and makes it easier to maintain and update the code as your projects evolve. Welcome back. In this lesson, we'll take a look at the console, which is an important part of the developer tools that every modern browser has. To open the console in Google Chrome, you can right-click the page, click Inspect, and then select the Console tab. There we go. So what exactly is the console, and why do we need it? Well, there are a couple of things we can do with the console. For example, we can execute JavaScript code directly here, like the alert command that we used in the last lesson. When I run this, we see a pop-up appear on the page. This is great when we want to test a specific line of code before adding it to our code editor. As JavaScript developers, we often use the console to output information about our program. In other words, to test if our program works the way we expect it to. But how do we display information in the console? For this, we can use the console.log command. So in Visual Studio Code, just write console.log and then a pair of parentheses. Everything we write inside the parentheses will be displayed in the console. For example, we can output the text "Hello World." This will log "Hello World" to the console. We can also write expressions inside the parentheses, like a mathematical operation, such as 10 plus 10. Then JavaScript evaluates the expression and prints the result 20 to the console. So the console is a very important tool that helps us analyze our code. We're going to use the console log command a lot in the future, as we learn the basics of programming in JavaScript. Another important thing about the console is that JavaScript uses it to communicate with you. This means that when JavaScript finds an error in your code, it will display an error message in the console. For example, if we make a typo and forget the G in the console.log command, then we're going to see an error like uncaught type error console.lo is not a function. This means you're trying to run a function that JavaScript doesn't recognize because there is no console.lo function. Along with the error message, JavaScript will also show you where exactly that error is. It's telling you which file and line. For example, line 2. This information helps you fix the problem. As a programmer, you will always run into issues in your code. To fix them, you can use these error messages in the console to find the cause of the problem. Most of the time, it's just a typo or a missing character. But sometimes the errors are more complex. In those cases, Google is your best friend. JavaScript has a huge community, so there's a good chance that someone else had the exact same problem, and you can just copy and paste your error message to find help online. And of course, these days you can also ask AI tools for help. Now that we have taken the first steps in JavaScript, we can finally start learning the basics of programming. Let's do that in the next lesson. Welcome back. In this section, we're going to learn the fundamentals of JavaScript, the most important tools that every developer needs to know. Before we can build real projects, we need to understand the core building blocks of JavaScript. Think of this part as learning the grammar and vocabulary of the language. During the first few sections of this course, I will use Run.js to show code examples instead of Visual Studio Code. This has the simple reason that Run.js makes it easier for us to focus on the JavaScript code. I write the code on the left side, and we can immediately see the console output on the right side. But for you, I would recommend that you keep working in Visual Studio Code. Just use the script tag to embed a JavaScript file, just like we did in the previous lessons. Then you can code along with me. The code will work exactly the same way, no matter which kind of editor you use. So if you want to follow my code examples, you can simply write the code in VS Code and then open the console in the browser to see the result. So feel free to follow along in VS Code while I use Run.js on screen. Use whatever tool feels more comfortable for you. Both will work just fine. Welcome back. Let's start with the fundamentals of programming. We begin with variables. This is one of the first concepts you need to understand when learning a new programming language. In this lesson, we will talk about what a variable is, how to create one, and how to store values in it. Let's start with the question, what is a variable? In programming, a variable is an abstract storage location paired with a symbolic name that holds data, like a number, text, or more complex data types. Alright, not entirely clear yet. Let's try a simpler explanation. In programming, a variable is like a box. It holds data. The main purpose of variables is to store some information in them. In programming, each variable has a name, like score, username, or age. It describes what kind of data it holds. Variable names help the programmer and the program quickly find and use the data that is stored inside. So it's very important to always choose a variable name that is self-explanatory. As you will learn later, we can store different types of data inside a variable. For example, numbers, booleans, strings, or objects. These are all different data types, and we're going to talk about them in the next lessons. Finally, the content of each box is the variable's value. The content can change over time, just as you can replace what's inside a box. I hope this analogy makes sense to you. Let's dive into practice and create our first variables. To create a variable, we can use the keyword let, followed by the name of the variable. For example, username. And that's it, we just created a new variable. This is known as variable declaration. When we declare a variable, we create storage space in the memory and give it a name by which we can access it later. For now, the variable does not have any value. To put a value into the variable, we select the name of the variable, username, and use the assignment operator. Here we can assign a value, for example, Tom. This assignment operator assigns a value on the right side to a variable on the left side. You probably know this symbol from math, but it's not the same thing. So don't confuse it with the equal symbol, which is used to represent equality. We use the assignment operator to give a value to an existing variable, not to compare them. Assigning a value to a newly declared variable is called variable initialization. So we initialize the variable. We can assign values to variables in two different ways. The first way, as we did it here, is to assign a value to an existing variable after the variable has been declared. The second way is to assign the value at the time of declaration, meaning on the same line. After creating a variable, we can use it in our code, for example, printing it on the console just by accessing the variable. Of course, when we refer to a variable, we don't use quotation marks, just write the variable name. Now we can see the value of the variable in the console. Next, let's talk about how to reassign a value to a variable. To do this, just reference the variable by its name and assign a new value using the assignment operator. If we do this a few times and console log each time, we can see how the variable changes. Now we see a different name for each console output. That's because the JavaScript interpreter reads our code from top to bottom and updates the variable after each console log. But what happens if we try to print the variable in the console before the variable is declared? So let's move the console log up here. In this case, I would get an error message, because I tried to reference a variable which is not defined at that stage. So you always have to keep in mind where you created your variables. It is usually a good practice to create the variables at the very top of your file. This way you can avoid these kind of errors. Let's briefly talk about constants. We know that we can override the values of variables. But sometimes our programs may need variables whose values will remain constant. We want to protect certain values from being changed and overwritten. In this case, we would use the const keyword to declare a variable. The const keyword allows us to create a constant variable whose initial value cannot be changed. Const variables are often used for things like mathematical constants, API endpoints, file paths, or any other value that should not change. Naturally, when I create a const variable, it must be declared and initialized at the same time, in the same line. Now if I try to assign a different value to the variable, then I get the error message, type error, assignment to constant variable. So now we have learned how to create variables using the let and const keywords. Both keywords were introduced with ECMAScript 6 in 2015. Before that, we used the var keyword to create variables. I don't recommend using var now, but it's still important to be aware of it, as you may encounter it in older versions of JavaScript. Maybe you will see someone else using var variables on the internet. Before we finish the lesson, let's talk about some important rules and conventions for naming variables. There are a few key rules you should always follow when naming variables. Rule number 1, start with a letter, $, or underscore. A variable name cannot begin with a number or a dot, but it can contain numbers in the middle or end. Variable names must not contain spaces. They have to be one consecutive piece. Number 3, avoid reserved keywords. Keywords like const, function, or class are reserved for specific purposes in JavaScript, and they cannot be used for variable names, because they will change the meaning of the code. Here are some examples of valid variable names. Let a, color, underscore private, $button, gets top 10, and so on. Apart from the naming rules that we have to follow, there are also some naming conventions that come from the community or the language itself. For example, camel case. You should use camel case when your variable has more than one word. Then the second word should start with an uppercase letter. Choose descriptive and meaningful names. Good variable names clearly describe the data they hold or the purpose they serve. Try to be as short but also precise as possible when naming your variables. Let's summarize the key points of this lesson. In this lesson you learned about variables in JavaScript. You can create variables using the let and const keywords, depending on whether you want the variable to be changeable or constant. When creating a variable, we first declare it and then initialize it. The value is assigned using the assignment operator. We should always strive to name our variables in a meaningful way and avoid using names that are very short, unclear, or difficult to understand. Welcome back. In the previous lesson, you learned about variables. We talked about the let and const keywords and how you can store information in variables. But there's actually a little more to that, because so far we have only stored text values. However, in programming, we often want to work with different types of data. That's why in this lesson, we focus on data types. Data types are fundamental concepts that you will come across in any programming language. In JavaScript, data types are divided into two main categories. Primitive data types, such as string, number, boolean, undefined and null, and non-primitive data types, like object and array. In this lesson, we'll focus on primitive data types. One data type that we already used is text, also known as string. A string is a sequence of characters, like letters, numbers, and punctuation marks. It can also contain special symbols like the $sign or emojis. The string is one of the most common data types. It is used in practically every programming language. You will use strings for things like names, countries, food, and any other sequence of characters you can think of. To create a string, we wrap a piece of text with quotes. For this, you can use single quotes, double quotes, and even backticks. They basically do the same thing. But the backticks are a little bit special because they allow us to use string interpolation, which we'll explain later. Let's move on to the next data type, number. As the name suggests, the number data type is used for storing numeric values. You can create a number variable by simply assigning a number to a variable. Of course, here we don't use quotes. The number speaks for itself. There are two different types of numbers, integers and floating point numbers. An integer is a whole number, such as 1, 12, or 1000, whereas a floating point number is a decimal number, such as 0.2 or 5.5. In JavaScript, both integers and floating numbers are simply called number, whereas other languages like Java have a separate data type for floating numbers called float, but we don't have that in JavaScript. They're all just numbers. So now we have seen two types of data, number and string. But why is this important for us? Couldn't we just write everything as a string? Not really. The reason is different data types are treated differently. To demonstrate this, let's use the addition operator. When we perform a simple calculation, like 7 plus 4, then JavaScript will return the result of that calculation, which is 11. But if we turn these numbers into strings by using quotes, then the strings will be combined. So instead of 11, we get the result 74. By the way, this is also the case if only one of the values is a string. So this example shows us that variables with different data types will behave differently. When we use the plus operator on a string, JavaScript will combine the strings. If we do the same thing with numbers, JavaScript will perform the calculation. Now that we have seen how to use string and number, let's continue with the next data type, because some information cannot be represented with just a string or number. For example, is the user logged in? Or is the user old enough to enter the website? In this case, we use the data type Boolean. A Boolean can have one of two possible values, true or false. Think of it like a light switch. It's either on or off. It has only these two states, true or false. To create a Boolean variable, just assign true or false to a variable. Boolean variable names are usually statements like has access or is logged in. This makes it clear that the variable contains a true or false value. This way, when we use the variable later, we can easily answer the statement with yes or no. In programming, Booleans are mainly used to make decisions in your code. They're often the result of an expression. For example, we can use the age variable we created earlier and check if the age is greater than 20. This is called a comparison, because we compare the values with each other. Currently, it is true. We can see that when we print it in the console. The result is true when the age is greater than 20. If you set a smaller value for the age variable, the result would be false. Now we can use this Boolean in an if statement to control what happens next. Don't worry if this looks a bit advanced, we'll talk more about these concepts in the future. For now, remember that Booleans are mainly used for making decisions and controlling the flow of your program. Let's recap what we have learned about data types. Strings are used to store text, like words, sentences, names, or any other sequence of characters. They are wrapped in quotes and can include anything from letters and numbers to symbols and emojis. Numbers are used for numerical values, which include anything related to counting, measuring, or doing math. Numbers can be integers, like 10, 50, or 1000, or floating point numbers, like 2.5 or 0.1. Booleans are simple but powerful. They can only be true or false. Booleans help us make decisions in our code. For example, we can use Booleans to check if a user is logged in, if a task is completed, or if an item is in stock. Booleans allow your code to respond differently based on certain conditions. Welcome back. Let's talk about operators. Operators are the foundation of any programming task. Whether you're calculating the score in a game, checking if a user password is correct, or determining the price of a product in an online store, you will be using operators basically all the time. In this lesson, we'll give you a general idea of what operators are. You don't have to understand everything just yet, because we will discuss all of these operators in separate lessons. Let's start with the question, what is an operator? An operator is a symbol that tells the computer to perform a specific action on values or variables. This action could be anything like adding, subtracting, or comparing values. Then the operator will return a new result. For example, when you write 5 plus 10, then the plus symbol is the operator. It performs the addition on the numbers 5 and 10. The result is of course 15. The values of variables that the operator works on are called operands. So in this example, 5 and 10 are the operands, and the plus symbol is the operator. Most of the times, operators work with two operands, which is known as a binary operation. Examples include addition, subtraction, multiplication, and also comparison. However, some operators work with just one operand, like the increment or decrement operators. They are called unary operators, because they only need one value to work. There's also a ternary operator, which works with 3 operands, but that is a bit more advanced. Let's get a brief overview about the different operator categories. Most of the relevant operators can be grouped into 4 main categories: assignment operators, used to assign values to variables; arithmetic operators, used to perform basic math operations like addition, subtraction, and more; comparison operators, used to compare two values like checking if they are equal or greater than each other; and logical operators, used to combine conditions like and or. Of course, we have already used some of these operators. For example, the assignment operator, which allows us to set and update variable values. There are more assignment operators that we'll cover soon. In the next lesson, we'll start by looking into arithmetic operators and how they help us to perform math. Later on, we'll explore comparison and logical operators to see how they help us to make decisions in our code. Let's get started. Now that you understand what operators are, let's start working with them. We'll begin with arithmetic operators. Arithmetic operators are used to perform calculations on numbers. Here we have 2 variables, a and b, 10 and 5. Usually we should use more descriptive names for variables, but just for simplicity we'll stick with a and b. Now we can use these variables in various arithmetic operations. For example, if we write a plus b, we use the addition operator. On the console we get the result 15, because 10 plus 5 equals 15. To subtract one number from another, we can use the subtraction operator, a minus b. The result is of course 5. That's pretty simple. For multiplication, we can use the asterisk symbol. This is the multiplication operator, which gives us the product of 2 numbers. In this case, it's 50. For division, we use the slash symbol, the division operator. Here we get the result 2, because 10 divided by 5 equals 2. So far, nothing special, because we all know these operators from school. But there is another arithmetic operator that might be new to some of you. It's called the modulo operator. Modulo is represented by the percent symbol. For example, if we write a modulo b, then we get the result 0. Why is this? The modulo operator basically calculates the remainder of a division. Here, 10 modulo 5 gets the result 0 because 10 divided by 5 leaves no remainder. This is basically a simple way to check if a number is divisible by another number. If we change b to 6, for example, then 10 modulo 6 gives us 4, since 10 divided by 6 leaves a remainder of 4. The modulo operator is very useful. A common use is to check if a number is even or odd. By using the modulo operator with 2, you can easily determine this. If a number modulo 2 gets the result 0, we know that this number is even. If the result is 1, the number is odd. The last operator I want to talk about is the exponentiation operator. It uses 2 asterisk symbol. This operator returns the result of raising the first operand to the power of the second operand. For example, if we log 4 to the power of 3, then we get the result 64, because 4 times 4 times 4 is 64. This is just basic exponentiation. So that's a brief overview of the key arithmetic operators. I hope everything is clear so far. Now let's take it a bit further, because you can also combine these operators. For example, here we write a plus b times b. What do you think will be the result? Expressions are usually processed from left to right. However, here they have to follow the rules for operator precedence. As you already know, multiplication has a higher priority than addition. So the program will first multiply b and b, which gives 25, and then adds 10 to 25, resulting in 35. If you want to change the order of operations, you can of course use parentheses. This changes how the calculation is performed, just like it works in math. Of course, when working with operators, we don't have to use the result right away. Instead, we can just store the result in variables and then use them later. For example, declare a variable product and assign the result. Then the variable product contains the result of this multiplication. Let's look at another way to use arithmetic operators. Sometimes we want to update a variable's value by using the variable itself in the operation. Sounds complicated? Again, let's look at an example. Imagine you have a variable age that stores a person's age, that is 18. When this person turns 19 years old, then you need to update this variable. The logical approach would be to set the age variable to 19. While this method works, it's not always practical, especially when you don't know the exact value of the variable. For example, if the age comes from a database or another source, you won't always be able to just set it to a new value, because we don't know which value we have to set. Instead, you can update the variable by adding to its current value. For instance, we can write age equals age plus 1. This will increase the age by 1. So we take the age variable, we use the assignment operator, and then we use the age variable again. Here, the age is going to be 18. And then we say plus 1, so 18 plus 1 is 19. We use the variable itself to adjust its value. This might seem a bit counterintuitive at first. If this were math, it would not make sense. But it is a common practice in programming. Remember, even though the assignment operator looks like the equal symbol from math, it is not the same operator. So here we add 1 to the current age and then assign the result to the age variable. To make it even simpler, there's a shortcut for this, the addition assignment operator. Instead of writing age equals age plus 1, you can just write age plus equals 1. This does exactly the same thing. It adds 1 to age, but in a more concise way. It is the combination of the addition operator and the assignment operator. So these two lines of code do basically the same thing. They increase the age variable by 1. This shortcut is a handy tool for updating variables efficiently. And of course, there are similar shorthands for the other arithmetic operations. For example, the subtraction assignment, which decreases the variable by a specific number, the multiplication assignment, which multiplies it, and so on. I would recommend you to experiment with these different assignment operators so you really understand how they work. By the way, whenever you want to increase a variable by 1, it is a good practice to use the so-called increment operator. For example, to increase the age variable by 1, we can just write age plus plus. This basically does the same thing as age plus equals 1. So this is an even shorter way to write this. It's called the increment operator. And as you may have guessed it, the decrement operator, which you can use by putting 2 minuses next to the variable, decreases the variable by 1. So now you have learned a lot of different operators in this lesson. This topic might be tricky for beginners, so I encourage you to experiment with these operations in your code and try things out yourself. And of course, always remember to do the exercises after each lesson. Now let's move on to comparison operators. What is a comparison operator? Comparison operators allow us to compare two values. Think of them as making a statement or asking a question. For example, you might say, is the username equal to Tom? Or is 5 greater than 6? JavaScript checks these statements and gives back an answer, which is either true or false. If the statement is correct, it returns true. If it's incorrect, it returns false. A comparison will always return a boolean. Let's look at some examples. Suppose we have a variable x with the value 5. We can use different comparison operators to check this variable. Let's start with the greater than and less than operators. For example, we can check if x is greater than 7. JavaScript looks at this and sees that 5 is not greater than 7, so it returns false. Now let's try checking if x is less than 7. This time it returns true, because 5 is indeed less than 7. If we change the value of the variable x, let's say we change it to 10, then the results will flip. Now x is greater than 7. So the first comparison is true and the second one is false. Now let's talk about another comparison operator, the equal to operator. It checks if two values are the same. For this we have to use two equal signs. But why 2? That is because we already used the equal symbol to assign values to variables. So we need 2 of them for comparisons. If I write x double equals 10, we get the result true, because x is equal to 10. But if you check x double equals 4, it will return false, because x is not 4. Of course, we can also compare other data types like booleans or strings. For example, to check if a password is correct. Pretty simple. So let's move on to the next operator. It's called greater than or equal. This one checks if the value on the left side is either greater than or equal to the value on the right side. To use it, just write greater than followed by the equal symbol. For example, 5 is greater than or equal to 5. This returns true. When I increase the first operand, it is still true. But if it is less than 5, this statement is false. Of course, there's also the less than or equal operator. As you might expect, it works pretty similar. This operator checks if the value on the left side is less than or equal to the value on the right side. The last comparison operator we'll cover is the not equal operator. It uses an exclamation mark followed by the equal symbol. This one checks if two values are not the same. If you compare 10 and 6, saying 10 not equals 6, it returns true, because 10 is not equal to 6. But if I say 10 is not equal to 10, then it returns false because they are actually equal. So this was a brief overview of the most important comparison operators. But before we conclude this lesson, I would like to mention one important point. In JavaScript, we also have the strict equality operator. This one uses 3 equal signs. The key difference between normal equality and strict equality is that the strict version also checks the data type of the values. For example, if we use the normal equality operator, like 5 double equals the string 5, it will return true, even though one of the operands is a string. But if we use the strict equality with 3 equal signs, then the result will be false, because the types don't match. One is a number and the other one is a string. Using normal equality can sometimes be fine, but it can also lead to unexpected behavior, because of loose typing in JavaScript. For instance, comparing false to 0 will return true. Undefined is equal to null for some reason. You can even compare an empty string with 0 and that is still true. If you search for JavaScript memes on Google, you'll find many jokes about these odd comparisons, because this aspect of JavaScript is pretty weird. That's why in most cases it's better to use strict equality to avoid these pitfalls. By the way, there's also a strict inequality. Just use 2 equal symbols after the exclamation mark. Comparison operators are very important in programming, because they allow us to make decisions in our code. They let your program evaluate conditions and decide what to do next based on the outcomes. In the next lesson, we'll dive into how to use these operators for decision making in your code. Welcome back. Now that we have learned about comparisons, you might be wondering, what's the point? The point is that we can use these comparisons in conditional statements, like if statements. If statements are a fundamental concept in programming, because they allow us to make decisions in our code. They give our programs the power to adapt and respond to various scenarios. Here are some examples. In a weather app, you might use if statements to display different icons based on the forecast. If it is sunny, you show a sun icon. If it's rainy, show a cloud with raindrops. For an e-commerce website, if statements could determine the shipping costs. If the order total is over $50, then offer free shipping. Otherwise, charge $5 shipping fee. In a game, you might use if statements to check if a player has won. For a login system, it could be used to verify the password. These are just a few examples, but as you can see, conditional statements are everywhere in programming. They help us make our program flexible and able to handle different scenarios. They control the flow of our code. So this is where our program really gets interesting. Let's start with the syntax of if statements. You start with the keyword if, followed by parentheses. Afterwards, you type curly braces. Inside the parentheses, you write a condition. A condition is something that can be true or false. For example, a comparison, like age greater than 20. If this condition is true, the code block inside the curly braces will be executed. If the condition is false, it's going to be ignored. So, in this example, if the age is greater than 20, we will see the output in the console. But if the age is not greater than 20, then the code block will be ignored. So when we set age to 19, we don't see an output. That's pretty simple. You have the if keyword followed by a condition. If the condition is true, the code block will run. If the condition is false, the code block is skipped. We can create conditions for all kinds of comparisons. For example, when the user entered a password, we can check if the password is 1234. Then we can tell them that this is not a safe password. In another example, we can ask if the Boolean variable is true. For example, to check if a website is finished loading. By the way, whenever we compare a Boolean variable to true, then we actually don't need the equality operator. We can simply pass the Boolean variable, meaning we don't have to write finished loading equals true, but we can just say finished loading, because that will already return true or false. We don't need a comparison. We can simply pass the Boolean variable. Here, both if statements work the same way. These were just some examples how you can use comparisons as conditions, by comparing the variable to a certain value. However, you don't always have to use a comparison as the condition. A condition can be everything that JavaScript can convert into a Boolean. And since JavaScript is a loosely typed language, almost anything can be a Boolean. When a non-Boolean value is used as a condition, JavaScript will just turn it into a Boolean. A 0 and an empty string will be converted to false. And the same goes for undefined and null. So this code will not run. Most other values will be turned into true. If I use a number or a text, the code will just run. But this is really just a side note to demonstrate the weirdness of JavaScript. Of course, I would not recommend to do this. You should always use your conditions where it is clear that the result is a Boolean. For example, comparisons. However, it is important to note that JavaScript is weird and can use anything as a condition. Let's look at another typical example for if statements. Imagine the user has submitted both the name and the password using an HTML input. Our task is now to compare the password that the user entered with the actual password from our database. If they match, then welcome the user to the website by printing a welcome message for the user. So far, that's nothing new. But what do we do if the password is wrong? Then we have to tell the user that the password is wrong. Currently, it is just ignored. How can we do that? In that case, we need to use an else statement. Just use the keyword else followed by curly braces. The code that is written here will be executed if the first condition is false. Here we tell the user that the password is incorrect. So this is a common example of how to use if statements. You have a condition, like a comparison, and then if the condition is true, the first code block will run. If the condition is false, the else code block will run. And this is also why else doesn't need parentheses. We don't need to specify a second condition here. It is just going to refer to the initial condition in the if statement, and when it's false, the else code block will run. This is very useful if you have two different outcomes to a scenario. A password is either true or false. Then there's nothing in between. And of course, you can use the same logic in any scenario. For example, if the user is logged in, show the home page, and else show the login page. Or if the user prefers dark mode, show dark mode, else show light mode. However, sometimes we need to check more than one condition. In that case, we can use else if statements. Imagine we want our website to greet users in different languages. Let's create a variable called language to store the user's language. I'm going to set Spanish in this example. Then we add if statements to check which language the user speaks. We have Spanish, German, and English, for example. Now we want to add a different message for each language. If the language is Spanish, say it in Spanish. If the language is German, we have to console log this in German. This code works perfectly. Depending on the language, I get different outcomes. However, this is not the best way to write this code. Why? Because here the program checks every single if statement, even after finding a match. So, when the first condition is true, it will still check if the language is German or English, and this is not efficient. We want that as soon as one condition is true, the others below are skipped. For this, we need to use an else if statement. As the name suggests, this is a combination of an else and an if statement. Just use the else keyword after an if block and then start the next if block. Do this for both if blocks. Of course, you can check as many cases as you like. Now, if a condition is true, it immediately leaves the entire if block without checking the other conditions below. So if I set the language to English, it first checks if it is Spanish, and this is false. Then German is also false, and then if it is English, and that is true. So the code block will run. And if I set the language to Spanish, then only the first if block will be checked, since this will already return true. It doesn't need to check if the language is German, because our condition is already true. That is pretty great about else if statements. But what if the user entered a language that we don't provide? In this case, we can use an else statement for the entire block. This code will only run if no condition was true. Here, we simply print a message that we do not provide the language. Now, if the user speaks a completely different language, JavaScript will go through every condition. If every condition returns false, the else block will run. I hope you understand everything so far. Let's summarize the key points of this lesson. If statements are one of the most important concepts in programming. They allow you to control the flow of your code by making decisions based on specific conditions. These statements give your program the ability to adapt, respond, and execute different actions depending on whether certain conditions are true or false. The if statement starts with the keyword if, followed by a condition inside parentheses. These conditions are usually questions. The answer is either true or false. For example, is age greater than 20? If the condition is true, the code inside the braces runs. If the condition is false, that code is skipped. Sometimes you want to have code that runs if the first condition is false. In this case, you can use the else keyword. It provides an alternative path for the code to follow. Think of it as a backup plan. Then the code inside the else block will just run instead. Sometimes you need to check more than one thing. That's when else if is useful. Else if lets you check another condition after the first if condition. And if the first if condition is false, the program moves to the else if to check the next one. And it keeps going until it finds a condition that is true. Once it finds a true condition, it runs that code and ignores the rest. If you only use if statements and no else if statements, then it's going to check every if statement, no matter if it already found one that is true. It's going to check if condition after if condition. With else if, you can stop once you find a true condition. You can also include an else statement at the end of an else if block if all conditions are false. Welcome back. Today we are diving into another fundamental concept in programming: loops. Loops are very important because they allow us to repeat actions in our code without having to write the same code multiple times. In JavaScript, there are different types of loops. The most common ones are for loop and while loop. There's also the do while loop, but it's not used that often. And we also have a for each loop, which we'll cover later in this course. Today we'll focus on the for and while loop. Let's take a look at the syntax and how they work. The simplest type of loop is the while loop. It looks a bit like an if statement. Between the parentheses, there's a condition. This could be a comparison or a boolean. Anything that can be either true or false, just like in an if condition. But here's the key difference. As long as the condition is true, the while loop will keep running the code inside the curly braces over and over again until the condition becomes false. So let's take a look at this example. A simple way to use a loop is with a counter variable. Then we use the while keyword followed by parentheses and curly braces. Inside the parentheses, we have to write the condition. For example, counter less than 10. Inside the curly braces, we put the code we want to execute. Here we simply log the counter to the console. If we run this code now, we have a problem, because this condition is always true. The counter is 0 and it will always be less than 10. So the loop will never stop. The code will keep executing for eternity. This is called an endless loop or infinite loop. When the condition will never be false, the loop will never stop. And of course, we have to avoid this. To avoid this, we have to do something that will cause the condition to become false at some point. For example, we can increase the counter variable by 1 after every iteration. Just write counter plus equals 1 or counter plus plus. This will increment the counter variable. Now the program will count from 0 to 9. Let's break down what happens here. At the start of the program, we create a counter variable and set it to 0. In the second line, we start the while loop. It's like saying, as long as the counter is less than 10, do the following things. So the computer checks if 0 is less than 10. Since this is obviously true, we enter the loop. The computer shows us the number 0 because the counter is 0. Then we add 1 to the counter. Now it's 1. So the computer goes back to the start of the loop and checks if 1 is less than 10. And this is also true, so we do it again. It prints 1 and increases the counter by 1. So it is 2 now. Is 2 less than 10? Yes. So this keeps happening, showing us the number 2, 3, 4, and so on. And only when the counter becomes 10, it is not less than 10 anymore. So the condition is now false, and thus the loop stops. This is how a while loop works. It just keeps doing something over and over until a condition is no longer true. Welcome back. Let's talk about for loops. A for loop works pretty similar to a while loop, but it is more specialized when it comes to tasks like counting. The syntax looks something like this. We have the keyword for, and then a set of parentheses. Now here's the main difference between a for and a while loop. In the parentheses of a while loop, we have to declare a condition. But here, inside the for loop, we have usually 3 expressions that are separated by a semicolon. The first part is called initialization. This is where you set up a counter variable. So this happens before the loop starts. Now you write a semicolon. The second part is the condition, similar to what we did in the while loop. This condition is checked before each iteration. As long as this condition is true, the for loop continues. If it is false, the loop stops. So this is exactly like the while loop. Now you write another semicolon. The last part is the increment or decrement. Here you update the counter variable after each loop iteration. So this happens after the execution of the code inside the curly braces. To fully understand for loops, it is very important to know when these expressions happen. So let's break down what happens here. The loop begins by setting I to 0. I is our counter variable. Before each iteration, it checks if I is less than 10. If true, it runs the code inside the curly braces. After each loop iteration, I is increased by 1. The condition is then checked again, and if I is still less than 10, the loop runs again. This process repeats. Check the condition, if true, run the code. Update the counter. Check the condition, run the code. When I finally reaches 10, the condition becomes false and the loop stops. So this for loop does essentially the same job as the while loop from the previous lesson, but now with fewer lines of code. For loops are often the better choice when it comes to counting tasks, because everything you need is packed inside the parentheses. You have the initialization, the condition, and the increment steps all in one place. This makes the code more organized. Doing this with a while loop, you would have to set up the counter variable before the loop and update it inside the loop. This can cause trouble because imagine you have a very complex algorithm inside the while loop. In that case, you can easily forget to increase the counter variable, which leads to an infinite loop. So a for loop makes it easier since everything is organized in one place. Let's briefly recap the differences. For loops are great when you know exactly how many times you want to run the code. They're perfect for counting tasks. While loops, on the other hand, are suited for situations where you don't know exactly how many times you'll need to loop. You just keep going until the condition becomes false. Welcome back. In this section, we're going to talk about functions, more specifically how we can create our own functions. We have already seen how to use some functions that JavaScript provides, like the alert function that creates a pop-up window in the browser, or the console log function which prints something on the console. These are just two of the many built-in functions in JavaScript. In fact, JavaScript has over 1000 built-in functions that we can use. Some other examples include the date function, which gives us the current date and time. We have many string functions to manipulate text. For example, toLowercase changes all letters into a lowercase letter. There are also a lot of math functions, such as math.random, that generates a random number. These built-in functions are incredibly useful because they save us a lot of work. But what if JavaScript doesn't have a function for something we need? And that's when creating our own function becomes important. In this section, you're going to learn everything you need to create your own functions in JavaScript and how you can use them effectively in your code. Functions are a very big topic in JavaScript, so we're going to take our time exploring them step by step over the next few lessons. But don't worry, we'll keep things simple and practical. Let's start with the question, what is a function? Functions allow you to write reusable and organized code. In almost every application you will build, there will be tasks that need to happen again and again. Imagine you're building a platformer game. The player needs to jump whenever a button is pressed. Then that jump might involve moving the character up, playing an animation, and maybe even trigger a sound effect. You don't want to rewrite all of that code every time the player jumps. It would be like copying and pasting the same set of instructions over and over again. And that's where functions come in. You can think of a function as a set of instructions bundled together to achieve a specific outcome. So instead of rewriting the code every time, you can write the code once inside a function, and then call that function whenever you need it. For example, whenever the player presses the jump button, we call the function jump. In the next few lessons, we'll cover everything you need to know about functions in JavaScript. Welcome back. Let's start using functions in our code. The syntax to define a function is very simple. We start with the keyword function. Next, we give the function a name. For example, say hello. When naming a function, we should try to make it as self-explanatory as possible. So when you see that function later, you will know exactly what it does. The name follows the same rules like a variable, for example. It always needs to be one piece, there are no spaces allowed, and usually you write this name using the camel case syntax. In this case, say hello contains 2 words, so I simply write the second word, hello, with a capital letter. After the name, we add a pair of parentheses. These will be useful later when we pass additional information to that function. But for now, we leave them empty. And finally, we add a pair of curly braces. Here, between the opening and closing curly brace, we'll put all the code we want to execute. This is called the function body. So the code in here will run when the function is called. For example, console log, hello world. Now when I run this code, nothing happens. We cannot see anything on the console. That is because we have only declared the function, but we haven't told JavaScript to execute it. When we create a function, we just store some code that we want to execute later. This is called function declaration. But to make the function actually run the code and perform its task, we need to call it. You call a function by writing its name, followed by a pair of parentheses. Now when we run this code, the function will execute. On the console we can see hello world. The awesome thing about functions is that you can call them as many times as you like. Let's see what happens if we call say hello several times. Now hello world will be displayed 4 times in the console. That's because every time we call the function, the code in the curly braces will be executed. So essentially, a function is a reusable block of code. You might be wondering, why do we need a function when we could just write the console outputs right here, instead of calling a function? But imagine you have a complex program, and we call this function from many different places with a lot of code in between. This function should greet the user by printing hello world. But what if I later decide to greet the user in a different way? For example, hello username. Then I would have to go to every place in the code where I greet the user and change the output. This is very tiring and can also cause errors in your code. So that is another advantage of using a function. When we use a function, we only need to change the code in one place. And it will be applied automatically every time we call the function. So functions will save you a lot of time. They help you keep your code clean and readable, especially if you have more complex functions that contain loops, if statements, or complex algorithms. Then it will be very important to write efficient and organized code that everyone can understand. So far we have learned that a function is a reusable block of code. It allows us to perform a specific task when we call it. But right now our functions always do the same thing. For example, the sayHello function always prints hello world to the console. If we had more instructions inside the function, such as a for loop, if statements, etc., it would still perform the same set of instructions every time. This is the simplest kind of function. But what if we want the function to be more flexible? For example, what if we want to greet a different person every time we call the function? This is where parameters and arguments come in. They allow you to pass values to a function and then use this value inside the function. To use a parameter, we have to specify it inside the parentheses of a function. Create the parameter and call it name, for example. But of course, we can call it whatever we want. It's like a variable. Now this parameter only exists inside the function. So it's basically like a local variable. Let's use the parameter. For example, in our console log, hello plus name. But how can we assign a value to this parameter? Currently, it is just an empty placeholder. When we call this function, we get the output hello undefined. That's because the parameter is currently empty. To assign a value, we have to pass the value when we call the function. Inside the parentheses, we need to pass a value. For example, Tom. We can do this by either creating a variable and passing the variable, or by directly passing the value inside parentheses. Say hello, and then in quotation marks, Tom. Then the parameter will have the value Tom. As we can see in the console, it says hello Tom. The value we pass to a function is called argument. This is very important to remember. We have a parameter and an argument. The parameter is part of the function declaration. This means we create the parameter when we create the function. And the argument is the actual value that we pass to the function when we call it. So here we're assigning a value to the parameter. This has the advantage that we can call the function several times, but with different arguments. We can say hello Tom, Chris, Alice, and Sarah. Now the function greets a different person every time. We can also use more than one parameter in a function. You can use as many parameters as you want. Let's create a new function. Add numbers. It should add 2 numbers and then print the result to the console. For this we need 2 parameters. We call it num1 and num2. They are separated by a comma. To add even more parameters, just write a comma and then the name of the next parameter. But for this function we only need 2. Inside the function we can simply print the result, console log num1 plus num2. Now when we call the function, we need to pass 2 arguments for the parameters. We pass the numbers 5 and 3, for example. The result will be printed in the console, which is of course 8. When we have 2 or more parameters, the order of the arguments is really important, because it determines in which order they are assigned to the parameters. 5 is the first argument, so it will be assigned to the first parameter num1. 3 is the second argument, so it will be assigned to the second parameter, num2. When we call this function a few times, we get different results every time, depending on the values we pass to the function. Now let's do a little exercise to get comfortable with these parameters and arguments. Try to implement the functions for the other basic arithmetic operations. This means subtraction, multiplication, and division, so that when you pass two numbers, it should always print the correct result on the console. I will give you the solution in a few seconds. Alright, I hope you tried it. For this, we simply copy the add numbers function a few times because these functions are very similar. We only need to change the name of the functions. For example, subtract numbers, multiply numbers, and divide numbers. The parameter names can stay the same because they're local to the function. Then we only need to change the operator in the console log, the asterisk for multiplication and the slash for division. And that's all. Now when we call those functions, we should get the correct answer. Welcome back. Let's talk about the DOM. The document object model is kind of a bridge between JavaScript and the web page. Think of it like this. Let's say we have a simple HTML page with an h1 heading and a paragraph. Now what the DOM does is that it takes your HTML code and turns it into a tree-like structure. Each HTML element becomes a node in this tree. This structure allows JavaScript to access and manipulate every part of your web page. In other words, the document object is just a JavaScript representation of your HTML code. And this allows us to access and manipulate each node inside this tree. So we can select and interact with every HTML element on the page. For example, to access the body, we just have to write document.body. If you print this on the console, you will see the body element displayed. So here we're accessing the body node in the DOM tree. With the document object, you can do all kinds of cool stuff. For example, change the text content, modify the CSS style, remove HTML elements, or create new HTML elements. You can also work with form elements to handle user input or use event listeners to make your page interactive. Once you learn how to use the DOM, you can build just about anything. For example, a simple to-do application, mini-games like cookie clickers, scroll animations that respond to user scroll position, or even complex applications like a chess game. But before we get there, we need to master the basics. In this section, we'll start with the core foundations of the DOM. Here's what you will learn. We start by learning how to select HTML elements on the page, using methods like getElementById or querySelector. Then we'll talk about how to modify text and HTML content on the page, how to change CSS styles using the style property, and how to modify attributes of HTML elements. After that, we'll dive into one of the most important topics, event-driven programming. Think of everything the user does on the page as an event. For example, clicking on a button, submitting a form, hovering over an image with the mouse. In JavaScript, we can create event listeners, which allow us to say, when this event happens, run this block of code. For example, when the user clicks on a cookie in a game, we can run the code to increase the score and update the counter. By the end of this section, you'll be ready to build interactive web pages that respond to users and feel alive. So let's dive in and start exploring the document object model. Welcome back. Let's start working with the document object model to build dynamic and interactive websites. As always, we start with an empty HTML page and add a JavaScript file, app.js. In our HTML, the only thing we need is a script tag that links to the app.js file. But there's one more important thing to keep in mind. We have to include the defer attribute in our script tag. Why? Because the defer attribute ensures that our JavaScript runs after the HTML has completely loaded. This is crucial because now we want to modify the content of the HTML page. If our JavaScript code runs too soon, the HTML won't be available yet. It is not fully loaded. When the elements are not fully loaded, there's nothing we can work with in the code. This can lead to many errors. So I highly recommend using the defer attribute whenever you work with the DOM, because that way it will always wait for the entire HTML to load, and only then it will run the JavaScript. Alright, let's use the document object to modify our web page. How do we do that? For that, we use a special JavaScript object called document. Let's open the console and take a closer look at this object. When we print the document object, we will see something interesting. the console will display the entire HTML structure of our web page. That's because the document object is a representation of our HTML page, but in a structure that JavaScript can understand, a JavaScript object. However, this document object contains way more than just your HTML code. It's more like a toolbox for interacting with the page. It is full of different properties and methods you can use. To get a better look at all the properties, let's use the console.dir method, and then pass the document object. This will show us a huge list of properties. We have things like the URL of the page, the character set, and of course the properties head and body. Apart from that, there are many other properties we can use to interact with the DOM. These are all the parts of your HTML page that you can control with JavaScript. For example, let's try accessing the body of our HTML. Since the body is part of the document, we can access it using document.body. This returns a JavaScript object that represents the body element and everything inside. The body itself also has many properties we can work with. For example, inner HTML. The inner HTML property allows us to set the HTML code of elements, in this case the body element. But as you will see later, inner HTML works for all HTML tags that we select in JavaScript. Let's add some content to the page. For example, the string hello world. Document.body.innerHTML equals hello world. Now we can see this text on the web page. In the web inspector, we can see the text inside the body tag. Of course, this is just a boring string. To turn it into a heading, just surround it by an opening and closing h1 tag. Here we can see the h1 inside the body. So we have added our first HTML element to the page. Now, what if we want to add more elements to the body? A button, for example. Let's copy this line and assign a button with some text. Now the heading is gone and we have a button instead. That is because we override the inner HTML property with another element. What do you think would I need to change to have both elements, the heading and the button, on the page? To do this, before assigning the button, we access the inner HTML of the body, and then add the button. So with this inner HTML, we first get all the elements that are currently inside the body, and then we add a new element to this. If we want to have a button above the heading, we can simply change the order. First the button and then add the inner HTML. But what if we want to add an HTML tag in between both elements? This would be very tricky to achieve using inner HTML. That's why the DOM has better methods to modify the HTML. You will learn more about them in later lessons. But for now, inner HTML is a simple way to add HTML to the page. Alright, now we know how to change the content. Let's take it one step further and learn how to change the style of elements. For that, we can use the style property. Each element in the document has a style property that we can use to modify its CSS. To use it, simply access the style property of the respective element. Document.body.style. Let's log this. Here we can see a lot of properties. If you are familiar with CSS, you may recognize some of them. So basically everything we can style in CSS can also be styled in JavaScript. However, there's a slight difference in how these properties are spelled in JavaScript. In JavaScript, we don't use the dash for multi-word properties because the dash is the subtraction operator. Instead, we use the camel case syntax. For example, background color becomes background color with a capital C. So let's change the style of our page. We access the style object of our body. And then we use a CSS property, for example, color. Now we can assign a color, for example, blue. This will make the heading turn blue, because as you probably know, the color property addresses the text color of all elements inside. To change the background color, we use the style property again, select the background color and assign light blue. Alright, that was a brief introduction into the document object model. What have we learned so far? We have talked about the document object. It serves as a representation of the entire HTML page. It contains many properties and methods that allow JavaScript to interact with the HTML. For example, the inner HTML property. We can use it to easily modify the HTML code. In addition, we learned how to use the style property. Every HTML element contains the style property, so we can use it to directly modify the CSS styles of our elements.
So now you have learned the essential building blocks of JavaScript. You understand the syntax, you have seen the logic. So you can already build simple programs on your own.
But this is just the beginning. If you want to really master JavaScript, here's what is next. You'll need to dive deeper into DOM manipulation, learning how to change, animate, and respond to everything that is happening on the page. That is the key to building real frontends, interactive apps, or even browser games. Next up is mastering arrays, objects, and methods that will let you work with huge amounts of data. This is crucial if you want to build websites professionally. And if you want to understand JavaScript on a deeper level and build meaningful projects that you can add to your portfolio, then you don't have to figure this out all on your own. Because we at Coding to Go created a full JavaScript course on Udemy. It's over 7 hours long, with video lessons exactly like these you have seen in this video. But we also go deeper with coding exercises, learning quizzes, and big projects that are designed to teach you JavaScript as fast and effectively as possible. So if you enjoyed this crash course, then I'm sure you will enjoy the full course even more. Click the link in the description to get a discount on the course, and I'll be happy to see you in your first lesson.